Hello, ladies and gentlemen, and thank you for watching my presentation. I am Gouya Anass from University of Science and Technology, Mohammedia, Morocco. Today, I will talk about optimization of parameters on the failure stress behavior of standards using Taguchi method. My show begin with a motivation following by the materials of work. After the analysis by Abacus, we'll have Taguchi designed results and discussion will be the last part of this presentation. Why ropes have long been used in many industrial and civil engineering applications. Their actual use dates back to 1836 by the engineer Wilhelm Albert. They are unique in that they have a high tensile strength yet remain flexible enough to be rolled up before and after use. Furthermore, as they are made up of several wires, they have the advantage that they do not break suddenly. The ropes are used for lifting loads, bracing bridges, securing floating structures, pre-stressing concrete structures, transporting electricity, and also in the automotive sectors. In the field of civil engineering, there are mainly three types of structure made of cables. Cable stayed bridges, suspension bridges, and pre-stressed concrete bridges. The main functions of the cables in a structure is to transmit the load from deck to the support pillars. Suspension bridges and cable stayed bridges or to compress the concrete. In this work, we focused on the analysis and the effects of design, manufacturing, and operating parameters of wire ropes. On the failure stress, behavior of central core strands of 19 multiply 7 wire ropes. We have chosen a 19 multiply 7 wire ropes using different types materials like copper, aluminum, and steel. The geometric models are imported into Abacus. One extremity of the finite element models is fixed and the other free extremity is subjected to tensile loading. The displacement of the free extremity is largest and decreases from the free extremity to the fixed extremity. In addition, mesh there are different formulations of elements in the finite element method. For this model, the elements used in mesh are C 3D8R. This type of elements is defined as linear break with 8 nodes, reduced integration time increment, control for the discretization of the strand elements with the mesh pitch of the order of 2 millimeter. The number of meshes is equal to 39,403. These parts contain the Taguchi design. Our aim is to find the optimal conditions. We have choose Young's module, winding angle, and diameter of course using 3 levels. And here is a table shows the 27 tests using the Minitab software without forgetting failure stress. Numerical analysis of the strand failure stress properties was performed on the 27 strands models with different configurations to maximize the failure stress, considering the option larger is better. Table is an extension of figure. It represents the calculated average signal to noise ratios and the optimal parameter to release high performance metallic cables according to the signal to noise failure stress. The larger is better. We output the optimal condition, the main effect plot of the signal to noise ratios. The, the optimal conditions are Young's module E equal 200 gigapascal, winding angle O equal 229.19 degrees, and the last one diameter D equal 1.9 millimeters. The integration of experiments DOE with the finite element method FEM and design is done to appreciate the effects of parameters such as material type, geometric shape, winding angle, and their interactions on the mechanical behavior of cables. A Taguchi experimental design to optimize the optimal parameters, the effects of the optimal condition on the failure stress was studied. We varied 3 factors on 3 levels. The confirmation test of the signal to noise ratios based on the failure stress, the, the objective of the Taguchi method applied in this work is not only to improve the quality of the wire rope but also to reduce the manufacturing cost. The simulation values of the first model are compared with the analytical values and the error is 8.30%, which is reasonable. Thank you for your attention.